Helping learn, inspiring minds, building futures. Explore the fundamental concepts of inheritance and polymorphism in Java, key pillars for robust and flexible software development. Understanding object-oriented programming, OOP, in Java. Object-oriented programming, OOP, is a paradigm based on the concept of objects, which can contain data and code. Java is a popular OOP language. Key OOP principles include 1. 2. Encapsulation, inheritance, bundling data and methods that operate on the data within a single unit, restricting direct access to some of the object's components. A mechanism where one class acquires the properties and behaviors of another class, promoting code reusability. 3. 4. Polymorphism, abstraction, the ability of an object to take on many forms, allowing a single interface to represent different underlying types. Hiding complex implementation details and showing only the necessary features of an object. Inheritance, building on existing foundations. Inheritance is a core OOP concept enabling a new class, subclass, child, to acquire properties and behaviors, methods, from an existing class, superclass, parent. Code reusability, avoids redundant code by allowing subclasses to inherit common functionalities. Is a relationship, establishes a clear hierarchical relationship, e.g., a dog is a type of animal. Runtime polymorphism, essential for method overriding, enabling dynamic behavior. Syntax example. Class child class extends parent class, additional fields in methods. Polymorphism, many forms, one interface. Polymorphism, meaning many forms, allows a single interface to represent different underlying types. In Java, it's primarily achieved through compile time polymorphism, method overloading, runtime polymorphism, method overriding. Multiple methods in the same class share the same name but have different parameters, number or type. A subclass provides its own specific implementation for a method already defined in its superclass. The compiler determines which method to call at compile time based on argument types. The Java Virtual Machine, JVM, determines which method to call at runtime based on the actual object type. Method overloading, flexibility and functionality. Method overloading allows you to define multiple methods with the same name within the same class, provided their parameter lists differ. This enhances readability and reusability. Signature difference. Parameters must differ in type, number, or order. Return type can be the same or different, it does not participate in overloading. Compile time decision. The compiler decides which overloaded method to call based on the arguments passed. Example. A versatile calculator class calculator. Int add, int a, int b, return a plus b. Double add, double a, double b, return a plus b. More overloads can be added, e.g., for 3 integers int add, int a, int b, int c, return a plus b plus c. Method overriding, customizing inherited behavior. Method overriding is when a subclass provides a specific implementation for a method that is already defined in its superclass. This is crucial for achieving runtime polymorphism. Same signature. The overridden method in the subclass must have the exact same name, parameters, and return type, or a covariant return type, as in the superclass. Access level. The access modifier cannot be more restrictive than the overridden method's access level, e.g., public to private is not allowed. Runtime decision. The JVM decides which version of the method to execute based on the actual object type, not the reference type. Add override annotation. Recommended to ensure correct overriding and help the compiler catch errors. Example. Specialized animal sounds class animal, void sound, system.out. println, animal makes a sound. Class cat extends animal, add override void sound, system.out. println, cat meows. Key restrictions in method overriding. To maintain the integrity and predictability of overridden methods, Java enforces several crucial restrictions, cannot reduce visibility. An overriding method cannot have a more restrictive access modifier than the method in the superclass, e.g., cannot change public to private. Checked exceptions. The overriding method cannot declare new or broader checked exceptions than the superclass method. Unchecked exceptions are not restricted. Final methods. Methods declared as final in the superclass cannot be overridden, ensuring their implementation remains unchanged. Static methods. Static methods belong to the class, not instances, so they cannot be overridden, though they can be hidden by a static method in the subclass. Private methods. Private methods are not visible to subclasses, making them inaccessible for overriding. Overloading versus overriding. A clear distinction. Feature. Method overloading. Method overriding. Polymorphism type. Compile time, static, runtime, dynamic, method signature. Must differ by parameter type, number. Must be exactly the same. Return type. Can differ. Must be same or covariant. Access modifier. No restriction. Cannot be more restrictive. Inheritance needed? No. Same class. Yes. Superclass, subclass, final, static methods. Can overload. Cannot override. Why master these concepts? Understanding inheritance and polymorphism is not just academic, it's essential for writing professional, scalable, and maintainable Java applications. Enhanced reusability. Greater flexibility. Polymorphism enables you to write more generic and flexible code that can handle different types of objects dynamically. Inheritance allows you to reuse existing code, saving development time and reducing errors. Easier maintenance. Robust architectures. Code written with these principles is easier to debug, extend, and modify as requirements evolve. They are foundational for designing robust and well-structured software systems. Thank you for learning. Connect with HelpigLearn. We hope this presentation has inspired your mind and helped you build your